Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills that they need to get their first software development jobs building Windows and web apps at some of the world's best companies as quickly as possible. In this lesson, I want to get back into the C# programming language itself and talk about declaring variables. So just to begin with, let me throw an algebra problem at you, and hopefully you can see where I'm going with this. You've probably seen a simple algebra problem at some point in your education that looks something like this. 5 plus 7 equals x. And it would ask you to solve for the value of x. And without a lot of thought, you can easily figure out the right answer. So using that same thought process, take a look at this. X equals 7, y equals x plus 3, console.writeLine y. What would you expect to be displayed in the console window? The value 10, of course. You just read C# on your own without any of my help. It's common sense, right? It's pretty easy. Now, okay, honestly, there's a little bit more to it than just that. First, the x and the y, as far as C# is concerned, are called variables. And a variable is simply a bucket in your computer's memory that's capable of storing a value. So you can put stuff, values, into the bucket. You can retrieve stuff, values, out of the bucket. You can put new stuff to cover up the old stuff in the bucket. And in this particular case, these buckets are just holding numeric values, but we could create buckets that are just the right size for dates and times, for strings or passages of text, for really, really big numbers, or numbers that have values after the decimal places, and a lot more. So in the case of this little code snippet on screen right now, we would expect both x and y to hold numeric values. Now we know that, but we have to use C# to express that to the .NET Framework runtime. So remember, the runtime is what does the hard work of managing the execution of our application. And part of its responsibilities is to allocate memory for our variables that will hold data. So here we have two data items, x and y. And we have to tell the runtime to allocate some space in memory sufficiently large enough to hold numeric data like that. Okay, so let's begin by creating a new application to learn a little bit more about variables. So I'm going to write a little code, and then we'll talk about it, we'll break it down, explain what's going on, and then we'll add some more code after that. But as we move forward in this lesson, the big takeaway is that a variable is simply a bucket in memory that you can put data into and retrieve data out of. All right, if we get that accomplished by the end of this lesson, we will have done quite a bit. Okay, so to get started in this lesson, I want to create a new project. There's a lot of different ways to do this. In the past, we've used File, New Project, and this time I'm going to just go to the Start page and click the New Project link on the home page. Either way, you're going to come to this New Project dialog. And so we want to make sure that, again, C# templates selected, filtered on the left, console application selected in the middle. That's the template we want to use. And then we're going to change the default name to variables, and then click the OK button. All right, and so what we're going to do next is type a bunch of code right here. Great. Now, before I do that, two little quick things I would really like to tell you about. First of all, watching a screencast tutorial is different than watching your favorite sitcom or watching a sci-fi movie. You need to be an active learner. The only way that you're really going to learn how to code is to actually get your hands dirty, get your fingers on the keyboard, and start typing. You need to follow along with me and actually type the code in yourself. It builds muscle memory. It gets you comfortable and familiar with the code editor. It builds your understanding and your familiarity with IntelliSense like we talked about previously. So do this. Pause. Rewind a few times if you must, but actually typing the code into Visual Studio is the single best way to learn. Secondly, all the same rules apply here that applied in lesson number 3. You have to type the code exactly. If you don't, you're going to experience some errors. You'll see those little red squiggly lines, or if you try to run the application, we'll get those error messages that'll pop up. And if you do run into problems, please refer back to the end of the third video, where when we created the hello world and then I showed you some of the possible things that could go wrong, like if you didn't put the code in the right place or you forgot a semicolon at the end of the line, use that as a reference. Okay, and let me say this. If you see me getting it working in this video and you can't get it to work, here's what people always tell me, and I had a college professor say this to my son in his previous semester in college. If you say to me, I did exactly what you did and I'm not getting the same result, I don't know how to put this nicely, but it's you, it's not me. You made a mistake typing in. Pay close attention to every single character that you type in. And at first, it's going to be difficult to ferret out where the problem is at. But over time, as you begin to think in C#, things will pop out at you. Oh, duh, I missed a semicolon. Read line is, it needs a capital R, capital L, and those sorts of things. Okay? All right, so let's go ahead and get started with those caveats. And we'll begin like so. And there we go. Okay. So the first two lines of code here, in lines number 13 and 14, are where we declare our variable. So to borrow from the explanation earlier in the lesson, we are officially asking the .NET runtime to allocate space in the computer's memory sufficiently large enough to store numeric values. We're asking it to create two buckets that will each hold values that eventually we're going to drop into them. After we've created those buckets, or those variables, we can begin to assign values into those variables. And most importantly, we're going to assign integer values into those variables. How do I know they're going to be integer values? Well, take a look at the keyword that we used in line 13 and 14. We use the keyword int. Int is the C# term for integer, a mathematical term that refers to a number that has no fractions or decimal values. It can contain very large numbers in C# from a negative 2,147,000,000 to a positive 2,147,000,000. Now, if you need to store a number that's larger than that range of numbers, then you're going to need to use a different data type. Or to continue our bucket analogy, you're going to need a bigger bucket to hold all those numbers. And there are many different kinds of data types. There are simple data types, complex data types, and then even later on in this series of lessons, you're going to learn how to create your own custom data types. But because I don't want you to be overwhelmed just yet, let's keep it simple for the moment. We're just going to talk about integer data types for now. In a moment, we're going to talk about the string data type. And then we'll add a few more data types along the way as you continue through this course. So after we've declared the variables, we can access our variables. We can assign values to the variables or read values from the variables that are already in the variable. And so we did all of that in the following lines of code, in lines number 16 and 17. We assign x equals 7, and then we read the value of x, append 3 to it or add 3 to it, and assign that new value, 10, to our variable y, and then we read the value of y in console.writeLine, passing in the value of y, okay? So the equal sign is an assignment operator. In English, that line of code is basically saying, set the integer called x to the value 7. And then we do the same thing in the next line of code. Set the value of, retrieve the value of x, 7, add 3 to it, and then assign that to the value of y, and then finally console.writeLine, retrieve the value of y from a variable, the variable y, which should be 10, and then print that to screen using console.writeLine, okay? So will it work? Let's go ahead and give it a whirl, and we can see that indeed we get the value 10 as we would expect in our console window. Okay. So now what we want to do is just comment all this out. So I'm going to use that format for commenting multiple lines of code like I talked about in one of the previous videos by using the / asterisk at the top, asterisk / at the bottom of the section of code that I want to comment out. So now, just to kind of drive that idea home, I run the application. The only thing that happens is the read line. I hit the enter key on my keyboard to continue on. Okay. So just as a side note, I want to leave this code here for you to reference if you were to download the code that's associated with these videos. However, I often take this approach whenever I'm writing code. I'll comment out some old code and I'll keep it around for a little while. I'll reference it while I'm writing new code that I intend to replace it. And then after I'm 100% sure that the new code actually works, then I'm going to go back and I'll remove that old commented out code. This is just one of the many little habits that I've developed through the years. This particular habit allows me to get back to the original code in case I make a mistake with the new code and I got to start all over again. Okay. So let's create another example. This time let's work with a different data type. So below this code that I've commented out here, I'm going to start in line 22 on my screen. I'm going to add the following before this console.read line and after this commented out section. Okay. Okay, extremely simple code example. Notice that in line number 22, that string is the keyword for creating a bucket in memory that can hold textual information. Think alphanumeric characters. Also notice that I can name my variables anything that I want within certain limits. Now as a convention, because most programmers do this, I use a lowercase m in my first name followed by a capital letter at the beginning of each additional word. So this is called camel case. And you should get into the practice of doing this too, because most programmers do this, especially for locally scoped variables. We'll talk about scope in a little while. So for now, let's just use strings and integers within our examples here and in the next couple of videos. But there are probably a dozen other data types that you'll eventually want to know, and we'll come across more, like I said, later on in this series of videos. And then obviously as you continue on in your C# education. All right, so let's go ahead and start debugging the application, and you should see the name that you typed in. I typed in Bob. At this point, our code example is really just a glorified variation on the Hello World example that we created back in lesson number 3. The only difference here is that I used a variable to hold the literal string Bob as opposed to the literal string Hello World that we typed directly into the console.write line. Okay, so before we move along, I want to re-emphasize from an earlier video that C# is a case-sensitive language, meaning that we can possibly add this line of code below the previous lines of code that we added. So let's just do this right here. String my first name, all right. And even though these two variables are spelled exactly the same, by virtue of the fact that the second variable declaration uses no capitalization, it means that these are two different variables. So this can be pretty tricky, and you should be cognizant of what you are typing. Be consistent and cautious whenever you're declaring and using variables. Now the good news is that Visual Studio will try to help you out as much as possible by correcting any capitalization mistakes that it can. However, the bad news is that there might be situations where you're on your own, just like this situation where you declare two variables with very similar names, spelled the same with different capitalization. So the best advice is always to be aware of what you're typing and why you're typing it, and to try and avoid using two variables with the same spelling but different capitalization. Of course, every rule is meant to be broken. There is a reason why you might want to do this. We won't talk about it in this series of lessons. I felt compelled to say that though. Okay, so let's move on. So let's comment out that line of code. We don't need that. One thing I do want to point out though is that I can condense these two lines of code into a single line of code. So let me comment these two out like so, and then I'm going to rewrite it like this: my first name equals Bob. So we can both declare the variable and initialize its value in one line of code. So experienced developers like to write less code. So they're always looking for a convenient way to reduce the number of keystrokes that they have to type and reduce the amount of code that they need to look at and to understand. So you should get into that practice as well. Now let me take this example one step further. Let me comment this out, and I'm going to go var my first name equals Bob. All right, and let's just run it to make sure it works, and it does. Okay, what is this var keyword? Is it a variable type? No, it's not. Several years after C# was created, a few innovations were added to the programming language to reduce the amount of code that you had to type. Now, while there's a long story behind why the var keyword exists, I imagine that you're probably going to see some code examples out on the internet or out on MSDN that use the var keyword instead of this longer format that we've been using, like int x or string my first name. So the idea is this. The C# compiler, you know, what takes your code and actually then turns it into a .NET assembly that will then be executed inside of the .NET runtime. So it creates that .exe file in our bin debug directory or our bin release directory. So the compiler. It's smart enough to see what you're initializing the new variable to contain. So why not just let it figure it out? Now it's important to know that in this case, the variable my first name is of data type string. It's not an unknown data type. And once we declare the my first name variable using the var keyword and initializing it to this literal string Bob, it can never hold any other data type, such as a number or a date time or anything else. So admittedly, in this mundane example, you may wonder what all the fuss is about. Why am I even talking about the var keyword? When we get into some more advanced examples later on in this series, you're going to begin to discover how important this new var keyword is. But it'll probably be like in lesson 20. So hang in there with me. Just wanted to introduce it here at the very beginning. It's important to note that you must supply a value to initialize your new var to. So if you don't, if we just did this, for example, let's comment that out and just go var my first name, and then I go to actually, I see a red squiggly line, I hover over, implicitly typed local variables must be initialized, okay? So, okay, again, you have to set it equal to something, even if it's just an empty string, okay? That will then tell the compiler, I know this variable is of type string. It can create the bucket in memory sufficient to hold a string, and then you can move on happily. And I'll have more to say about the var keyword near the end of the series, like I said before. I just wanted to introduce it here early on because it has become used so often in blogs and books and even examples in Microsoft's own documentation that if you didn't know that it exists, I think you might get a little bit lost the first time you see it. So just think of it as a shortcut to declare a variable, and that's it, at least at this point. All right, so let's move on and talk about how to convert one data type to another. When you convert one data type, like for example, my home address is 4110. Now I can put that in a string, but what if I wanted to convert that into the number 4110 so I can do some algorithm to see how many house numbers are in my town? I don't know. Okay, but that type of conversion where you're taking something from one data type and you're converting it to another data type, it's called data conversion. And so you might need, and you often will need, to know how to change a numeric value into a string value and back. All right. So we already know that you can't simply treat a string variable as an integer or an integer variable as a string because those buckets are sized differently based on the kind of data that they hold. So therefore, you have to perform a conversion of the data. So let's do this. Let's comment out everything up to this point. There we go. All right, so now I'm going to add the following code. Okay, so int x equals 7. Got it. String y equals Bob. Okay. String my first try equals x plus y. So I'm going to try to take a bucket that holds a number and a bucket that holds a string and pour them together into a new bucket that holds a string. How is that possible? How is it possible for our application to treat the integer 7 as if it were a string that it could concatenate together with another string to create a third string? Okay. Well, .NET allows us to implicitly convert x into a string so that it can combine, or rather concatenate, x and y together. This is an example of an implicit data conversion, a data type conversion that just works and we don't need to do anything special. .NET is smart enough to treat the integer 7 as an alphanumeric 7 to be used as part of a string. So what's going on behind the scenes is this. We'll take and call a toString method. All right. And you're like, whoa, where did this method toString come from? Okay, so most types in the .NET framework have methods defined that perform certain basic tasks like type conversion. So as a result of declaring a variable to be an int data type, we get a bunch of add-on features for free, whether we need them or not. They're baked into variables. More about this later, but you've got to admit that's pretty convenient, right? Okay, so notice that plus operator in line number 37. It's used here as a string concatenation operator. Now, if we're adding two integers together, it would change the meaning of this operator based on the context to be an addition operator. Just something to be aware of. Depending on what we're trying to do, it'll either concatenate or add two integers together. So we can rely on .NET to perform some implicit conversions. However, I recommend against this. You should never rely on implicit data conversions. I encourage you to always take control of your code and perform explicit data conversions. Otherwise, you're likely to introduce subtle bugs that are hard to find inside of your applications. So, how do you perform an explicit data conversion? Well, let's take this example and go one step further with it by adding this next line of code. All right, so immediately notice that there is a red squiggly line under x plus y. So do you want to take any guesses as to why that might be? It seemed to work the first time when we used my first try. Well, the reason is because .NET cannot reliably figure out a data conversion from a string into an integer. If it knew that the string was always something like 7 or 4110, then perhaps it could do it. But in our case, how is it going to convert Bob into an integer and add that to the number 7 mathematically? It can't. So in this case, we're going to have to explicitly convert data types. Explicit conversion means that we will have to write the code to perform the data conversion ourselves. Unfortunately, we can use some built-in features of the .NET framework, as we're going to do in a moment, but still, the onus is on us as developers to perform the conversion. Okay, so C# is a strongly typed language, meaning that data types must be declared and they must be honored. Therefore, when a situation arises where you need to use an integer where only a string will fit, then you need to perform the data conversion. It's the equivalent of cutting the corners off of a square peg so that it will fit into the round hole. So I'm going to demonstrate two data conversions in this lesson, from int to string and then from string to int. So let's comment out this line of code here. And below it, I want to write this line of code. Int my second try. Okay, so if you attempt to use the start button, you're going to get an unhandled exception dialog, and unfortunately the error message, if we were to hit break, we take a look at the error message, it says that the input string was not in a correct format. Now translating that into human speak, basically the application compiled correctly, however when the program was running, the value Bob could not be converted into an integer. So int.parse was expecting a value in the input parameter that it could convert from a string to an integer. Now in this case, as we said, Bob can't be converted into a number. As a side note, notice that the data type int has methods. Just like we saw earlier with the toString, it also has this parse method. And there's a really good reason why this is, which you may not appreciate until later, so I want to hold off on that until a little bit later. More importantly for our purposes in this lesson, by calling int.parse, we are explicitly telling the .NET runtime that we want to convert a string into an integer. And there are many different ways to explicitly convert one data type into another, and we're going to cover another one later on in this lesson. Usually it's preferable to explicitly convert data types rather than to allow them to be implicitly converted, like I said before. This makes your application less brittle and subject to special circumstances that you didn't foresee. All right, so let's stop running this application. And so to remedy this, what I want to do is comment out this line of code, string y equals Bob, and below it, I'm going to add string y equals the string 5. All right, so 5 surrounded with double quotes, which will make it a literal string. Also, what I want to do is go console.writeLine my second try so that we're printing out that new variable there. Great, and now let's run it. And we get the number 12. Great. Now let's do this. Let's comment out line number 44 and let's see what happens whenever we do the explicit data conversion on X. It occurred to me that we never actually ran this example now that we have X equals 7 and Y equals 5. Now remember, when we attempted to add those together and set them to my second try, we were able to print out the sum of those two values. Let's see what happens whenever we try to concatenate X, the integer of 7, and converting it to a string, and then concatenating it to the value of Y, which is now 5. All right, we get 75, the string 775. But those are just two alphanumeric characters, not really adding those two values together, okay? So the key idea in this lesson is how to declare, initialize, and work with variables and data types. In the .NET framework, even simple data types like the int have some powerful helper features, some methods that we're able to call to convert one data type into another data type whenever we need it. All right, see you in the next lesson. Thank you.